Well, with over 800 videos now on our YouTube channel, I know sometimes it's hard to actually find what videos that you're looking for, but I want to make sure you get this one because it is one of our more popular videos where me and Gerald actually talk about the difference between the Waterback and the Dryback boiler today on The Boiling Point. Gerald, this is a topic that I know when I'm out and talking with folks, and you're out talking with folks, that they have a lot of questions about. So let's kind of clarify some things. So why don't you go through it?
All right. Yeah, I'm kind of excited to talk about this because I repeat this a lot to a lot of different customers. So I wanted to kind of go through some of the clarifications between the dryback, the wetback, the engineering of it all, efficiency. Efficiency is obviously, it's a lot of the times confusing to everyone. Because there's a lot of ways to enhance the boiler being just a heat exchanger. I'm going to quickly kind of go through this part of it with the Victory Energy design. This is their centerfire dryback, a preferred design. I like this one a lot. It's engineered to optimize the water circulation, and that has a lot of benefits, particularly in process environments, the way you're able to manage the water. Also, it's engineered to promote good heat transfer, especially from the standpoint of the durability, where you have good even flow. It has a downdraft design, which is unique to it versus other types of drybacks. Right. So it's very durable design. And
I mean, I'm assuming that there's some maintenance issues, obviously, with it. That's not that much maintenance.
No, there's not a lot of maintenance, and I'm going to get into some of the details of that as we go through actual construction concepts of drybacks. So it's built for long-term performance. I can't say that all drybacks are that. A lot of the dryback designs aren't the best designs for, say, a process environment, where this design is very suitable for that. Also, when I mentioned efficiency earlier, people always confuse, say, thermal efficiency with perhaps combustion efficiency, or they say overall boiler efficiency. The true efficiency that you're trying to come up with is a fuel to steam efficiency. How much gas am I using? How much steam am I getting? That's the ultimate result. And the heat exchanger is only one piece of that. You may design it, to 5 square feet. You may be using CXID tubes or turbulators and things like that to enhance the heat transfer. But at the end of the day, it's how much fuel went in and how much steam came out. And the heat exchanger itself is only responsible for so much of that. A typical 5 foot square foot design versus another 5 square foot design is going to be 80%, period. If you add extended heating surface tubes, you can enhance that a couple of points. Because the heat transfer is better versus just a smooth tube. You increase the laminar flow, the tumbling, same thing like when you use a turbulator. You get the heat turning over, get the tube working completely.
Right. Now the XID tube, that's kind of it's not a new technology, but it has allowed us in the boiler industry to be able to do some more things, if I'm
Absolutely.
correct.
We've been designing with this for more than 12 years.
Right.
A lot of people had shied away from it early on because the combustion systems were struggling with the back pressure on that. Because the one thing about getting some back pressure and decreasing that flow through the unit allows that heat exchanger to work better.
Okay.
So you literally, you do get a benefit in where you increase the surface, so you actually incorporate that into the design. It's 23-25% additional surface, so you can make the boiler a little bit smaller. Or that additional surface also increases the productivity of the tube about 85%.
Okay.
So you could lower the surface, potentially, and utilize the calculations of the extra efficiency of the tube.
Right.
But one of the other things we like to do in our designs, in the drybacks utilizing the centerfire, is we have more productivity in the furnace. We like to do 55-60% of the work in the furnace. Let's get started early and not wait to catch up in the tubes, particularly in a process environment. I want to get the heat into the water as quickly as possible and not have to rely on the tubes to finish the job.
Right.
Typical boilers, and they do this because if you do less productivity in the furnace, you can make a smaller furnace. Furnaces are expensive to make. So if you do 45% of the work and then you just catch it up with the tubes. And that works in a lot of general lumbering heating applications. But we have a lot of critical process customers, and when they say, hey, I need heat, they mean I need it right now and I don't want to wait till later.
Right.
So we tend to lean on these kind of designs and incorporate the extended surface tubing in that.
And these are even in our rental fleet. We use those, that Dryback design as
Absolutely.
well. Yeah.
The other thing to note with Drybacks, and this is not special to this centerfire design or any one manufacturer, but you will tend to use less fuel, possibly up to 10% less fuel, utilizing a Dryback. And the reason that is, you've got this large heat sink in the boiler, so that when it actually cycles off, that heat sink will maintain pressure longer before the burner comes back on. Because the most efficient boiler is the one that's not running. No fuel's getting used.
Right.
So if we can keep that burner off longer and hold set point, you actually save fuel over time.
Sure.
So that's one of the benefits. I'm going to kind of show the construction process of a Dryback, because it's real confusing for people often to compare, what is a Dryback versus a wetback. It's real hard to grasp in your head on the wetback until you see some of this, and we'll show that later in this video. So here you have the centerfire design. The first pass is always the furnace. We're going to come back around in the second pass. Here we have a corrugated furnace, and then you have a turn section here. In the design and the centerfire design, we like this because we like the thermal stress on this one, because as it turns down and then comes back over, it's a much more uniform and even flow, kind of a circular heating flow. Plus, when we put the makeup water, the return water back in, we're not putting it in the hottest area, so it reduces sludging and things like that can cause additional problems. Here we're just showing what disengaging area actually is, and steam space. So you have storage in here where steam is actually in this chamber, but the disengaging area is a big deal as well. That's what allows the amount of heat to be made up quickly.
Okay.
And then these things, the outlets and the manholes and these things are pretty typical between whether it's a Dryback or a wetback.
Right.
That doesn't vary much.
Right.
Same thing with doors and so forth. Now the Dryback, and the reason why we like the centerfire as much as anything is everyone will tell you that Drybacks are high maintenance. And that's true for designs that aren't like this. And the reason that is the Drybacks of other designs, where they have multiple passes going from bottom to top, there are multiple pieces in the door. You have shelving, you have different materials, and you get a lot of expansion and contraction that leads to cracking and maintenance.
Okay.
All of our Dryback designs that with the centerfire concept, whether it be a 2 or a 3, which is the preferred engineering that we like to do, this is a 3-pass. It's kind of a keystone design, single piece. If it were a 2-pass, it would come straight across and be a half moon. Still a 1-piece design. We use a special material with a 0 expansion modulus up to about 3,000 degrees. And because we do more work in the furnace, the door sees the least amount of heat. Okay. We usually show about 600 degrees less than a typical 4-pass design.
Okay.
Now we're moving on to talk about the wetback design. I talked highly of the Dryback design. We also produce wetback designs.
Right.
So for us, it's not a prejudice where we have to lean on one or the other. We make these. They fit in a lot of great applications. I like this design pretty well, especially this 2-pass with this integral heat exchanger so that you can have less space. You don't have to have the economizer up high. So this is a unique design for us, and all the 2-pass wetbacks that we do. And being a 2-pass wetback is kind of unique as well. You can also have this in a 3-pass, but the 2-passes automatically come with it. And I'm going to get into kind of the construction of the wetback that's a little more difficult to understand. But here's what the extended surface heat exchanger would look like. It'd be right inside the shell, save you some space.
Typical economizers obviously are on top of the stack, so
Right.
that when you're saying that, that's actually inside here.
Yeah, as we go through this extended surface heat exchanger, then we exit the stack.
Right.
So it does save some space. It doesn't have to ship in a separate piece. It's a pretty unique design.
Okay.
We also can do the same thing in a 3-pass.
Sure.
In this one, it's not being shown, but we would come back through in the 3rd pass, and it would be integrated in here prior to the stack.
Okay. So we kind of get into the wetback design here then, and kind of show how it is actually made compared to what the Dryback
Correct.
was.
And this one is a little bit difficult to grasp. I love this presentation because it illustrates it pretty well. This is the internal wetback furnace. And the reason why, you'll see here in a minute why we call it a wetback or a waterback. We use the first pass in the furnace. We turn through this turn section without actually getting to the rear wall. The rear wall is separate,
Okay.
which you can see here. So here you have this internal furnace. Water is between the actual rear wall and that furnace. So we have stay rods that have to hold it into place. You've got a small plug opening that you can crawl through to get in this furnace.
Okay.
I can't crawl through it, but little people who can do this boiler work can. If I got in there, it would be a freak show because I'm a little claustrophobic.
Yes, you are.
So, but one thing to be concerned about here, and this is what I was talking about with the drybacks being able to stay off longer, all of the heat is integrated directly into water. And there are some benefits to that. But when you're modulating up and down a lot and the burner is going off, you'd like that rock there to keep it off as long as it can to use less fuel.
Right.
This is a very durable system, not unlike the dryback, but the durability of this is pretty exceptional because of all that integration. But I'm always cautious when people, they want to increase the size of the materials and all that. And this is a heat exchanger, so the way they last is to get the heat exchange properly. You can get away with a little more on the tubes and the tube sheets, but this furnace, when you start getting up above, say, 200 psi, gets a little unwieldy because it's also its own pressure vessel. So we might be 1.5 inches thick here versus 1.25 inches in a 200 psi design, and that's not in proportion to the rest of the unit. So if it's not properly heated, or it's cycling a lot, this can be a failure point and a very expensive one. With the dryback, not having that internal furnace, we can easily do 300 psi, not have to worry about that because there's nothing that's out of balance in the heat transfer.
Right. And just to clarify again, you've got your gases coming through the furnace, and they're staying in here to get through this.
Yeah,
this
they're going to get
furnace.
in here and come back through here.
Right, and again, illustrate the water is actually in this area.
Right.
Okay.
So there's your real
Yep, there's
tube
your real
sheet, just
tube
like
sheet.
it, just like in the dryback.
Right.
But in the dryback, you have the big door on the outside. In the wetback, you have the small little plug.
Okay.
So here is what it looks like. As you come down through here, the second pass of tubes is coming back over top of the furnace. This is a low offset furnace like a traditional dryback.
Right. And then they come through, turn again.
Turn again
And
into
get
the smoke
into
box,
the-
and now we're into the third pass. And then here you again have your steam chest and your disengaging surface.
Right.
And then the same things that you would see on the dryback,
Sure.
nothing really different.
Right.
But when you get to the rear door, it is uniquely different.
Okay.
And here you have this small plug that's leading into the furnace that you have to crawl through. If you have any tube stuff, someone's got to crawl into that little furnace and do the tube work
Okay.
versus standing outside the door
Sure.
and rolling the tubes.
Right.
So a special little dude does this. All right. So small hinge door, there's not much refractory there. Like I said, and refractory can be a repair issue. The one-piece design that we use does not have that kind of trouble. When you have the multi-piece, you should be concerned it's going to cost you some money every few years.
Right. Now, you have said we a lot in what we like to do, and we do have an announcement to make that we have selected Victory Energy as a partner of ours to actually make the fire tube boilers for us. So,
Correct.
why don't you maybe go through a little bit of the stocking program?
Yeah, we regularly stock, and we stock them more in a generic fashion since they could go anywhere in the U.S. at any time. Even though when we design for stationary units, we use a lot of higher technology, a little more efficient. This is more for emergency requirements. But the standard units are all 3-pass. We do utilize the XID technology, and most of all the units are low NOx. That tends to be the situation throughout the country. Everybody's looking to go to 30 ppm. So 3-pass dryback, low NOx is typical. We are going to have a standard power flame burner on it with linkage. We can upgrade them to say a parallel positioning or a higher efficiency burner, but this is the standard package. We carry them in most of the size that would be typical package range, from 50 all the way to 800 horsepower. We keep the larger units at a little bit higher pressure. They tend to be in more process environments.
Now you'd have more than one of each size. that
Yeah,
you're
we
carrying.
typically, among this group, will usually have a couple of dozen units in stock ready to go. So if you have an emergency of that requirement, give us a call. They're always available.
Well, there you have it. The difference between the Dryback and the Wetback. Gerald, appreciate you hanging out with us, and we'll see you next time on The Boiling Point.